Hey everyone, and welcome. Today, we are going to crack the code on a Cambridge A-level IT exam paper. But we're not just going to answer questions here. Oh no. We are going to build your ultimate revision guide, one concept at a time. Ready to turn this exam paper into your secret weapon? All right, let's dive in. Let's be real for a second. When you first open up a paper like this, it can be a little intimidating, right? You see all these complex questions, you know the clock is ticking, it's a ton of pressure. But what if you could look at this not as a test, but as a roadmap to acing your exam? Because that is exactly what we're about to do. Over the next few minutes, we're going to get inside the examiner's head, figure out what they're really asking for, and build a powerful strategy that you can take with you into pretty much any IT exam. So, let's get to it. Okay, first up, security. You can pretty much guarantee this topic will show up. Question 1B is a classic four-marker asking how a firewall protects a network. This is such a core concept in IT, and you have got to know how to nail it. So, how do you make sure you get all four of those marks? You just have to describe the process step by step. First, that firewall inspects every single data packet trying to get in or out of the network. Second, it checks each packet against a set of rules, kind of like a checklist. And finally, it makes a decision. Does it let the packet through, or does it block it completely? That simple, step-by-step logic, that's your ticket to full marks. I love this analogy because it just makes so much sense. Seriously, think of a firewall as the bouncer at a club. It's checking everyone's ID, that's the data packets, against the guest list, that's the rule set. If your name's not on the list, you are not getting in. It's a really simple, memorable way to lock this concept down in your head. All right, let's move on to the fundamentals. You know, these questions might look simple on the surface, but they're really testing your grasp of the core ideas that everything else in IT is built on. Get these right, and you're building a super strong foundation for the harder stuff. And question 2 is a perfect example. You're given these random bits, 47, 22, and PXR5G, and asked why this is data, not information. Well, the keyword here is context. Is 47 a temperature, somebody's age, a house number? Who knows? Without context, they're just raw, meaningless facts. But the second we add context, like seat 47 on flight PXR 5G, boom, it suddenly becomes useful information. Now for a 6-mark beast of a question, comparing mainframes and supercomputers. To nail this, you have to use clear, distinct characteristics. Think of mainframes as the ultimate multitaskers. They're built to handle millions of simple transactions all at once, like in a bank. Supercomputers, on the other hand, they're specialists. They focus all their power on one incredibly complex calculation, like forecasting the weather. Mainframes serve thousands of users at once, while supercomputers are often just for a small, dedicated team. Okay, question 9 is an 8-mark discuss question. Whenever you see that word, discuss, it's a massive clue. It means you need to give a balanced argument, pros and cons. So for a new business, buying off-the-shelf software is way cheaper, and you get support right away. The big downside? It might not do exactly what you need it to do. Custom-written software would be a perfect fit, tailor-made for you. But wow, is it expensive, and it takes a long time to build. To get those top marks, you've got to show you understand both sides of the coin. Let's get into how computers actually interact with the physical world around us. This section is all about sensors and control systems, basically the eyes, ears, and hands of our digital devices. Question 5 is serving up some quick, easy 1-mark definitions. A pressure sensor? It just detects physical force. A humidity sensor? It measures the moisture in the air. Simple, right? But the examiner is looking for precision, so get those definitions down pat. And now for the big one, an 8-marker describing an automated car park. The best way to tackle this is to think in a logical sequence. Okay, picture it. Step 1. A car drives into a space and a pressure sensor under the ground detects its weight. Step 2. That sensor sends a signal to a central computer. Step 3. The computer's software then reduces the spaces available number by 1. And step 4, the computer updates the big sign at the entrance with the new number. That's a perfect, complete control system loop. Next up, a quick definition of calibration. What is it? Well, it's just the process of fine-tuning a sensor to make sure its readings are actually accurate. You basically check it against a value you know is correct, and you tweak it until it matches up. You know, without good calibration, that car park sensor might not be able to tell the difference between a car and a really, really big cat. All right, welcome to the deep end. This section, covering algorithms and databases, is where you can really flex your logical thinking skills and scoop up some serious marks. So question 7 gives us a student's algorithm. And, well, it's got some problems. First thing to do when you see something like this, don't panic. Seriously. You just need to trace the logic line by line. Let's break down exactly what's wrong with this piece of code. Okay, here are the 3 big mistakes. First off, total is initialized to 10. Why? It should be 0, otherwise every calculation is going to be wrong from the start. So, the fix, total equals 0. Second, the count variable is increased before the number is even entered, which means the prompt is wrong. That line needs to move to the end of the loop. And third, the loop condition itself is just wrong. It should be comparing count to n, the variable holding the number of times it's supposed to repeat. 3 clear mistakes, 3 clear fixes. That's how you get the marks. Next, we have to contrast 2 types of loops. Here's the key difference you absolutely have to remember. A repeat until loop will always run the code inside it at least once. Why? Because it only checks the condition at the very end. A while and while loop, though, is different. It checks the condition right at the start. So if that condition is false from the get-go, the code inside that loop might never run at all. Now let's talk databases. Choosing the right data type for each field is all about being efficient and accurate. So for something like employee_name, well, that's easy, we use text. For hourly rate of pay, the currency type is the best choice to handle money properly. And for a simple yes or no field, like is manager, a Boolean data type is absolutely perfect. And finally, validation. This is how we keep our data clean and reliable. For the hourly rate of pay, you could use a range check to make sure someone doesn't accidentally type in $1,000 an hour. And for date of birth, a format check is great to make sure it's always entered in the same way, like DD/MM/YY. These little checks are essential for data integrity. So, what have we actually learned here? We've gone through security, hardware, software, sensors, logic, the works. Now, let's pull all of these ideas together into a rock-solid game plan you can use on exam day. Here they are, 5 key takeaways from breaking down this paper. 1. Read the command words. Discuss means something different from describe. 2. The number of marks tells you how much detail to write. Don't write an essay for a 2-mark question. 3. For any process question, think in logical, numbered steps. 4. When you're comparing things, use specific, distinct characteristics. And 5, maybe the most important, always trace your algorithms to catch those small but super costly mistakes. And there you have it. We've taken this exam paper from something to be scared of and turned it into a strategic tool for your revision. You've seen the logic, you've seen the patterns, so the only question left is, with everything you know now, what area are you going to go and master first? You've got this.